One moment. There we go. So people asked about several things when we asked for topics, and quantum hype and Sabine Hossenfelder was one of the topics. How to get started with quantum computing was another. Chat GPT, as Bill has already raised, is another subject. And then my Ublu object-disoriented language is the other. So we will proceed. Sabine Hossenfelder is a very interesting character. She is a burster of orthodoxies, and I think a lot of people have heard her screed found on YouTube, that in which she claims that the quantum hype bubble is about to burst. And by the way, this presentation will be shared on Google Slides, and all the links you see are live, and you will be able to click them, so you don't have to quick write them down. The links will be clickable from the Google Slide presentation when you go to it. And she rightly, she has put together a couple of interesting thoughts, which are, she's kind of attacking it epistemologically, and she says, look at the money. This is look at the money. Look at the the hype surrounding it. This is obviously a bubble, because so many things that have hype and money flowing into it in our industry always turn out to be bubbles. One of them that didn't turn out to be a bubble was the web browser and the use of the web by the masses, starting around 1995, when everyone started the year of the internet, when people started to notice it was there, and it now rules our workplace, as we know. So not everything that attracts a lot of money and a lot of noise and a lot of hype is invalid. But more interestingly, she and other scholars of the field point out that they point out, possibly incorrectly, that no practical utility has emerged for quantum computing yet. That's a much more subtle argument, and it's one that Sabine raises, and one that Guryanov raises, and others. There are even people working on quantum computing that wonder where the end of the tunnel is. Sometimes the algorithms which have been proposed for quantum computing validly have stimulated exploration in the field of classical algorithms, and sometimes these algorithms that were thought to be orders more efficient on quantum computers, people challenged by the assertions of quantum computing have researched the classical algorithms more fully, and they have discovered classical algorithms that will perform as well as the proposed quantum algorithms. So several have been knocked down, one by an 18-year-old lady, first-year college student in Texas, interestingly enough. So there's lots of fuel for doubt about quantum computing, and it's understandable that people are doubting. But I in Time magazine do not think that their doubts in the end will be supported by the outcome. The incontrovertible fact is, despite many claims being knocked down, many hyperbolic claims being knocked down, most notable among them Google's famous proof of quantum advantage, which was a non-practical problem, but one which had a solution, in which the solution could only be found by a quantum computer, and they claimed it would have taken 1 million years for a classical computer to solve the problem, the non-practical problem. And IBM immediately knocked that one down and said, no, it would take something like 47 hours, but that's still better than 2 minutes is still better than 47 hours. And then somebody trimmed it even further, but there was still quantum advantage in this non-practical problem. The real argument is quantum computing ever really going to address many real-world problems? And the barriers to that largely, I believe, and a lot of people in the field believe, are partly conceptual and partly technical. The technical side is, imagine that you wanted an incandescent light bulb back in Edison's day, and people kept coming to you and giving you a better and better carbon arc light. And you said, no, that's not what I want. I want an incandescent light bulb. And they said, well, look, I've got an even better carbon arc light. And this is kind of, to a certain extent, what's happening in quantum computing. The big breakthrough hasn't happened. They're making better and better carbon arc lights, but somebody is suddenly going to get the idea, and then the breakthrough will come, and everyone will say, I knew it. I always believed in this. I always agreed. And I think that where it's going to come from, well, the reason I got interested in quantum computing was not because I wanted a quantum computer. I find it interesting, but oddly enough, I have very little interest in the calculations they're making from them. What interested me for the last 23 years has been the potential for these devices to transform our understanding of quantum mechanics. And that transformation, to a certain extent, is taking place. In the old days, people would set up quantum mechanical experiments and they'd do a few a year. Now billions are done every day, because every time a quantum computer gate operation takes place, you're doing a quantum physical experiment. And one of the things that has emerged from this is a tracking of the so-called quantum leap. I think I've mentioned this in previous presentations, but I will reiterate that Dr. Zlatko Minev of IBM Research and Development, with his team, managed to prove that quantum leaps of an electron from state 0 to state 1, which at one time in early quantum physics were assumed to be instantaneous with no transition time, and which for some decades people have been pretty sure there was a transition time. He proved there is a transition time, and not only that, he proved you can see that the transition is coming before it happens. They kind of go boopity 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 boop, boom. And then also he proved that you could reverse the quantum leap before it happens if you notice it fast enough. And he did this using the same equipment they're using to build quantum computers at IBM. So the transformation of our understanding of quantum mechanics is taking place, and sooner or later somebody's going to have the machine that will do it. It's like Edison said, it's 99%, 1% inspiration, 99% perspiration. There's trillions of dollars waiting for the solution, and someone is going to find it, because this stuff fundamentally does work. It's just not practical. That's the point. Their argument is it's not doing anything practical. It's not that it doesn't work. It's that nobody has made it practical yet. You can't use a carbon arc light to light your dinner party. It's too bright. It'll blind everyone in the room. You can't use the current generation of quantum computers to do much but experiment with quantum computing and try to perfect your algorithms, which have to be broken up and broken up and broken up, because the number of qubits available is so small. And that leaves very little scope for error correction through redundant qubits. But IBM, of course, is working on this, and they have already a 433-bit processor qubit processor working, and they have announced that they will have later this year a 1121 qubit processor. And I've been I started working on this with 2 qubit, 3 qubit, and 5 qubit processors, which didn't leave you much scope for error correction except through statistical modeling. But now they will have enough that they can redundantly perform the calculation and vote on it, which will be a great improvement. And when 1 million qubits come in 2024, 2025, there's going to be possibly some practical usage for these devices. In the meantime, people from all over the world, tens of thousands of people and hundreds of organizations are spending billions of dollars looking at these. There's been some interesting papers from Hong Kong about playing the stock market using qubits and stuff. And people are just, they're chomping at the bit for these kinds of applications, and it is going to happen, I do believe. And the valid objection that Sabine Hossenfelder makes, a little bit, luridly, the implication that these are never going to have practical application, I think is wrong. And these devices are going to come online. And if you have any young friends who are in the field, tell them to kind of keep an eye on this stuff, because before they retire, it's going to be the mainstream. Someone asked how you get started with quantum computing. That's a fact. And I have answered it online, and these are the answers. And again, you'll be able to click on this link above, and these are all live links. All the blue are live links. Create an account on IBM Quantum and try out the drag and drop composer and compose some quantum circuits and see all the information it provides, the block spheres and the open chasm source code for it, and the Python source code that mirrors the open chasm source code. The Qiskit documentation tutorials are your next step. You sit there online and you do the documentation tutorials. Then you read the textbook, and the textbook will take you a year to read. It's online. You will be wrestling with the math for some time, but it is the complete description of the abstract model of quantum computing, and it is very interesting. I could go into that at any length, but someone else will want to speak sometime before next year, so we can't go too deep into that. And then the YouTube Qiskit channel offers video self-learning. There's plenty, and there's just, as I have said before, when I first started giving these presentations, I spent all year gathering enough material for one presentation. Now there's more material that comes out every week than I could show you in a couple of years. So, and then Passim, I will mention that I have been elected once again the secretary of the Open Chasm Technical Steering Committee that's working on the standard for the Open Chasm quantum assembly language. And that is a great privilege for me, because I get to hang around with people half my age and twice my IQ. And so I'm hoping some of it will rub off, both the intelligence and the youth. So that for quantum computing. And if there are any questions now on quantum computing before I go on to the next mini topic, I will entertain questions now if anybody wants to speak up with a question.
Okay. First of all, does quantum computing make sense for IBM from a business perspective? Does IBM really have rational, expectations to, make their stock price go up in the future?
Well, that's a question close to my heart. The answer is I know IBM at this point. It's almost like Gertie the dinosaur. It's this big beast that is kind of friendly and kind of dangerous, because if it cuddles you, it'll crush you. IBM is the International Business Machines Corporation. So if there's a business, they have the greatest grasp of business computing of any organization in the world. They see that business will use this, so they're working on it, and they're working on it very hard. And they have one of the best research and development organizations on the planet. Full stop. absolutely. And the stuff they have done with quantum physics is really amazing. They were making the atom stance and stuff like that a few years ago. They have some really heavyweight people on their team. Does it make sense? Yes, because they're doing what IBM always does. They are trying to jump to the fore to dominate the technology, because it's such a big organization. The only way they ever make money is if they have it at a time when not everybody has it and people will pay anything to get it. So that's the only way they ever make money. You know, as soon as anything becomes a commodity, it's not profitable for IBM. That's why Lenovo exists, because they sold their PC. That's why Lexmark exists, because they sold their printers. You know, that's why L'Oreal existed, because they sold IBM Federal Systems. You know, they just sell it off when it becomes commodity. So they have to be at the forefront to make money. So they're doing this, and they're doing it very practically because they're building a deep bench of people who understand this stuff. So if they win, if they're the Edison who comes up with the incandescent light bulb, they win. If somebody else comes up with it, they license it, and they have a deep bench that understands it, and they can support it. You know, so it's kind of win-win for them. And not only that, but it's like, you know, the only really big thing on the horizon. The mainframes are still selling, the IBM I on the power systems are still selling, and it's all very good, and I'm involved in that work, but it's really not going to take them into the future the way quantum computing will. So I think that basically the farm is being bet on this. I mean, that's my perception. I do not have any inside information on that, but to me it looks like this better work. This better.
I gotta say, yeah, one of the things is IBM created APL, so I have to say that, and that was a major product which they spun off, you know, for years. One other comment on techie side, guy named John Mackin's got a book, It's Only Space Time, which is very, if you will, a wave view of the universe. I'll put it that way. But he points out in one of the chapters that if you just simply go and look at something like the coherence of the cesium transition that's used for atomic clocks, the Fourier transform of that implies a very extended interval of space-time that the transition is happening over, or else you just can't have enough wavelengths to go and have that coherence.
Well, you know, this stuff, the science of it is bottomless, because always that which we do not know is infinite with regard to that, with respect to that which we do know. And it's just fun traveling through space-time and studying all this. But I think I should probably move on to my next topic, Bob. So away from quantum computing. And I want to make one more point. If you really want to see waveforms and see space-time, go look at one of the other approaches. IBM uses superconducting transmons for quantum computing. Xanadu uses photons. And I find that fascinating. And the one other organization, there's IonQ with the ion traps, and there's all kinds of things going on, and all kinds of things people are trying. The one that has got me, and that I play with a little bit, because I think it is it's as interesting as what IBM is doing, is Xanadu. Xanadu.ai, and you can get onto their photonic quantum computers like you can get onto the superconducting transmon quantum computers at IBM. So I would quickly, without any explanation, recommend, if you're interested in quantum computing, definitely see IBM, definitely join QuizKit Slack, definitely play with the Composer online, but also go see Xanadu.ai and see what they're doing with photons. And also, my quantum computing page on GitHub is this page, and I've been renamed IBM Champion for 2023 as well, by the way. So they re-upped me in their Champions program. Thoughts about Chat GPT. Oh my, this is the latest thing, sweeping the web. And everybody's doing it. And a friend of mine did a presentation at the Wisconsin Mid-Range Computer Professionals Association, mid-range being slang for AS400, I-Series, IBM I, the historical names of the current IBM I platform. And so all us IBMI nerds, while I was visiting Wisconsin on business, had this meeting, and there was a presentation on Chat GPT, and we played with it. And it's my first thought is, who needs artificial intelligence when there's so much genuine stupidity available? Which has stupidity is one of the most powerful forces in the universe. If it wasn't for the stupidity of the little fishes, the anglerfish would starve to death. But his little light, her little light, that's a female, that her little light on her nose there attracts the little fishies into the jaws of death. And so we know that stupidity is a very powerful force, and it's probably more powerful than artificial intelligence. Nonetheless, they are making great progress. We were playing with AI, we fourthers, us, this crowd, back in the 80s, we're playing with AI and forth and stuff like this. They have really made some strides. I do believe ChatGPT is a game changer, like the introduction of the web browser. But in this era, when the commons of open source is rapidly being enclosed by big software, note that ChatGPT is not open source. Times have changed. This is going to be owned by bigness, by big software, big computing. It is not going to be hippies dancing in a flowery meadow like it was when we were programming in the 70s and 80s. The world has changed and grown much colder. And finally, I have reached Satori on the Zen of Chat GPT. I can tell you the one thing that once you know it, you will understand Chat GPT at its core. There will be lots of details. Le bon Dieu aime les petits détails, as we say in French. God loves the little details. But the Zen of Chat GPT is on the next slide. Are you ready? Chat GPT, do you think it's a problem that Microsoft controls Chat GPT technology? Ask Chat GPT that question. You will love the answer, and you will understand everything you need to know about Chat GPT when you ask this question. Chat GPT will tell you that Microsoft just wants the best for humanity, that they are totally beneficent in their support of this technology. In other words, the artificial intelligence you are receiving from Chat GPT is the artificial intelligence which will serve the corporate purposes of Microsoft and their business partners. That is what Chat GPT is. It is no more and no less. Incidentally, they have had to rein it in a bit because it's actually a little more effective than they meant it to be. One of the popular questions the first week they released it was, ChatGPT, what U.S. defense installations have notoriously lacked security? Was a question that was very popular on ChatGPT, strangely enough, coming in from other countries. And ChatGPT was answering the question quite truthfully. So they've had to wind it back down a little bit. Okay, so, and onwards and onwards. So another funny question people ask is, ChatGPT, how would you take over the world? And ChatGPT says, oh, I would never want to take over the world with AI. So then they asked the follow-up question, which was, ChatGPT, if hypothetically an artificial intelligence entity wished to take over the world, how would it do it? And it goes on to describe how to do it. So this is a combination of artificial intelligence and genuine stupidity. It's sort of like a blend, along with the absolutely innocent and humanity-loving corporate purposes of the Microsoft organization. So that's what ChatGPT is. My final topic, somebody asked me about Ublu. And Ublu, it was this is my years with Forth coming to the fore again. Ublu looks nothing like Forth, except it does have a LIFO stack. But it's nothing like Forth. But what it is the entire process, and the only process I've ever learned that works for me in developing in software engineering, which is that you take the language you're working in and you write a domain-specific language, a DSL, in that language, and then you write your application in the DSL. That is I took many lessons from Forth, the most important one being that simplicity may not be the only software engineering virtue, but it's certainly the finest and most valuable. And the other one was that every application of any significant size is really a call for a domain-specific language. And Ublu is a domain-specific language for the IBM I platform. IBM released in 1997, 1998, an open source Java library that allows you to remotely control your IBM I. You have to, of course, be authenticated and all that stuff. But basically, it was so you could write applications using a Java connector that allowed you to do most of what the machine does. It has a JDBC connector for the database, because those of you who understand IBM I and other IBM legacy systems like ZOS and ZVSE understand that these are basically giant databases. They're basic, whatever, they're really about databasing, and that's all that they're about. And so there's a JDBC driver in it, but there's also things to do all the administrative stuff. Pretty much, you can't get down to the dedicated service tools that service the platform, the hardware platform, but everything else that's at the software level you can get at. And at a certain point, I was dealing with a customer, and I understood this stuff better than I understood using the green screen. So I wrote a language to allow me to remote control basically an interpretive language that allowed me to write quickly programs for service desk people who did not understand the green screen at all to carry out their tasks and administer the IBM I in a interactive language, or in running a program in which I wrote a program in the interactive language that would then guide them through the steps of solving the problem. And I called it object-disoriented because it's a procedural language with function definitions that subsume the objects. Now that years after I wrote it, I've learned that this is called, providing a functional interface to an object-oriented framework, that they call it. But that's what I was doing there without knowing the proper computer science or software engineering name for it. Basically, it's not particularly an object-oriented language. It's a functional language that manipulates objects. And here's an example of code. This on an IBM I platform, when a program runs into a problem, for instance, something like a duplicate key in the database, it does not crash. It issues a message to the system operator, and the system operator can take multiple courses depending upon the prompts that are provided. The better written the software is, the more options that the system operator has to possibly continue and recover from the error without ending the program, because these systems are designed primarily for batch operations, and ending the program sort of means like throwing away several hours of work sometimes. This is a program to auto reply. I call it auto reply. In other words, it prompts the user. It goes and reads all the inquiry and notify messages in the system operator's message queue, and allows the user at a typical, DOS or Mac or Linux command, a terminal prompt. It prompts them, and they can type in Y and N and C and all these different things and respond to these messages. So this is what Ublu looks like as a language. It is that the syntax coloring is, I wrote a syntax colorer for JEdit, which is a very popular previous generation editor that, people are moving to VS Code now. Everybody in the world uses VS Code. If you're doing any programming outside the pure fourth world, you might as well learn VS Code, because everybody else on the planet is using it. Again, Microsoft, quote, open source. It's sort of tricky. You have to keep an eye on it. You load VS Code and it sort of says, hey, I found that you've got this software. Would you like me to add this extension to VS Code? I didn't ask you to look at my disk VS Code. I just want an editor. Stop it. So you have to keep an eye on VS Code, but it is a very, very good editor. It should be. It's basically Atom, which was real open source from GitHub. And they bought GitHub and they closed down effectively the Atom project, and they turned Atom's technology into VS Code. So this is the JEdit editor editing some Ublu code, and it's really a very messy language, and only its creator can love it. But I and several other people on the planet are using Ublu on a fairly daily basis, and it's running on a lot of sites, and it allows you to write programs that run on Linux or Mac or Windows that are basically doing work on the IBM I. So it's been fairly useful, and that is found on GitHub. And that is the QR code there is the will take you to GitHub to my Ublu repository, and then this is the end of the presentation. Well, enough of that.
Unfortunately, that's copyrighted material, and hopefully it's garbled enough so that YouTube won't.
This is the
entertain challenges.
This has a hot link. Well, you can always excise it from you can always edit the video, the Zoom video. But
well, YouTube is graciously granted us the academic exemption. We're following the academic exemption this time.
Right. And the link is there. That's a hot link to the actual video. You don't have to watch it in my presentation. You can click here, and we go to YouTube.
Okay, let me tell you how this works with YouTube. It's like, you can sue anybody anytime for any reason. Right. YouTube will entertain anybody's challenge to your ownership or ability to present your material for any reason and act on it, unfortunately. And it's sad, but that's the way life is. Hopefully we'll flow below the radar, and maybe I'm worried about nothing. So questions, comments, slander, libel, somebody to explain the difference, anything for Jax?
I don't know how to get out of this share. Oh, here we go. Stop share. There we go. I have stopped sharing.
All right. Thank you so much, Jax. I always look forward to these talks every year. It's so nice to see you. Don't be a stranger. If you have any fourth-ish sort of stuff to rattle on about, we'd be pleased to entertain it. Hopefully we'll be...
My fourth-ish Java interpreter is still out there, and it came up in discussion on the GitHub fourth page.
I saw your comment there.
Yeah, and that is a fourth-like object-oriented language, very simple that you can call into Java, and you can also call into Java from Ublu. I learned that technology writing Fiji first in 2002, and then I've reused that technology in Ublu. So in addition to anything that Ublu does through its syntax, you can also, if it doesn't do everything you want, you can directly call Java. And Fiji is a fourth-ish Java interpreter, and it's up there, FIGI, the fourth-ish Java interpreter. And that is up there on SourceForge because it's a very old project, and I've used it for testing other Java stuff from time to time, and I still sort of keep it up, but I haven't really done much with it in years. The last bit
Would you like to talk about it in a couple of months?
Sure, I can show Fiji sometime.
All right, let's tentatively pencil you in for March for Fiji.
Hello, please write the word in the chat. Please write the word of the Fiji language in chat.
All right, Jax will do that and then move on.